Hello, I hope you're off to a good start with our Java class. In our first week, the first session, we wanted to do introductions. Those are posting on the discussion board and looking great. Make sure you get your introduction in and that you've commented with some nice information on a couple of other people's introductions. For the assignments this week, we're looking at chapter 15 in our book. And so there are a couple of resources here posted for you available now on Blackboard, or at least they will be as soon as I finish this video to add to it. The first thing I want you to open is the chapter 15 PowerPoint. But before we do that, let's kind of take a look at our Java course in Blackboard real fast. I'm going to switch to student view so that my screen will look like yours. And you normally, of course, will come into the announcement section of the course when you enter Blackboard. You want to take a look at your lessons. This is where we'll be keeping track of all of the information that's due. Right now, your course overview is available. You should have already been looking at that, I hope. If you click on the Getting Started link, you'll see that there is a lot of really good information out here for you, welcoming you to the class. Some requirements about our discussion board posts, requirements about the software that you're going to need for the class, and it's fine with me if you use Eclipse or Java Beans or any other editor that you like, as long as you submit code to me in a way that I can read. And we could always have some trouble with that, so let me know if you have something unusual going on so that we can work around it. You also have an introduction again to the Oracle iLearning. The link to the video isn't really responding very well in Blackboard, but you can click on this link down here and see it. I hope that you use that site a little bit in the first Java class and that you'll continue to refer to it as a resource. A couple of other websites that could be good resources for you: Khan Academy, Programmer, JavaDoc, and we have many, many others. So at any time, you're welcome to search for support. Please remember not to copy and paste code from another site. Just use those sites for informational purposes. Next, we have the Chapter 15 PowerPoint that goes along with our book. If you click on that link, it'll download for you. I'm going to let you take a look at that on your own. Be sure you do. And then we have some additional information, again, just some links about interfaces and abstract classes, because that's what we're actually talking about in this section. Remember, Blackboard always leaves breadcrumbs up here for you to return. So I'm going to go back to the course overview so that I can continue on. In our course overview, you also will find your syllabus quiz. With the syllabus quiz, again, you are able to use the syllabus, OTC's website, and Blackboard to complete that exam. It's just some really short questions, so if you haven't done it, please get that taken care of. Next is our discussion board post. So again, I hope that you found that and are working away. I've seen some great presentations so far. Now, when we get into the meat of our chapter, our assignment here for this week, we are looking at chapter 15. You are to complete exercise 15.6 in your book and zip up all those files and send them to me. Then you're also to complete 15.7 in your book. Again, you're going to be doing a zip file to submit these. We're working right now on getting everybody set up with GitHub accounts. So pretty soon I'll be giving you some information on that. And we may not continue submitting assignments this way, but that's what we're going to do for now. Please send me an email if you're having any trouble so that I can get back with you as quickly as possible. I'm in the process of moving, so email is probably the best way to get a hold of me. If you don't hear from me right away, don't worry. I'm probably like lugging some big heavy thing up a stair or something, and I'll get a hold of you right away. Lastly, for the week, you have the Chapter 15 quiz. This is the first time we've done a quiz over a chapter in our class for the spring semester. You're going to have 15 questions be worth 30 points. You can take the quiz 3 times and your highest score will be kept. What I ask is that since you have an opportunity to take the quiz multiple times, please don't use notes, books, or other resources while you're doing so. I want you to test your own knowledge and make sure that you're understanding the concepts, and that's why I'm giving you 3 times to take the quiz. If you feel like you don't do well the first time, please refer back to your book and notes and other resources before you try again. You have the opportunity. You can do that. Down at the bottom of the lesson folder, we have a summary of the different assignments for this lesson and their point value, so you know what things are worth. You can see how things are divvied up. So lesson 1 looks great. I'm going to go back to the announcement screen and I'm going to download. You can't see it because I am in, whoops. I'm going to skip this. I've got some other things going on my computer, and I'm going to exit out of the student view preview so that I can show you this announcement again. And again, it will be available to you by the time you can see this video. So in your announcements, your week 1 additional resources announcement, you should see a couple links. First of all, you have a link to the chapter 15 PowerPoint. This is a shortened version, just a quick summary. So let's go ahead and download that. And I'm going to open it. Now, taking a look at this presentation, we really have a review situation here. Before you start with chapter 15, you might want to find some coding challenges or something online. Do something to kind of refresh your memory about Java. It's been a little while since you've worked with it, and if you didn't have Java 1 last semester, it's been even longer for you since you worked at it. So remember, programming is all about practice, practice, practice. So do pull out a little bit of a practice problem. That's what we did in class. Try to work on something so that you feel a little bit more familiar with the language again. So chapter 15 is about abstract classes and interfaces. And in the past, in CIS170, we saw there were classes and superclasses. And remember, a superclass is just a class that we can inherit from. And we also might refer to that as the base class or a parent class. We have lots of different names for the same thing in programming, don't we? And whenever we are referring to a normal class that we can inherit from, we also refer to that as a concrete class. In this chapter, we want to get away from that a little bit and talk about abstract classes. Abstract classes are the next evolutionary step in our Java learning. We'll also, along the lines of this semester, be looking at wrapper classes and interfaces. Now, an abstract class is just like a regular class. It can contain data and methods, but we can't create an instance of an abstract class. So an abstract class is almost like a basis. It's like the blueprint for what we want our inherited classes to look like. So if we could create an instance of a class, it would be considered a concrete class. Again, with an abstract class, we can't create instances of those objects. Within our abstract class, we can have abstract methods. And if we have abstract methods in our abstract class, those methods are more of just a placeholder, a signature. And what they are is designed to tell any inheriting classes that they must override these methods. So we can't just have these abstract methods hanging around in our abstract class. When we inherit from an abstract class, we must implement those methods. So you can see how it's kind of a blueprint. It's like, no, I don't really want anybody inheriting from my class unless they make sure that they implement these methods too. So that way we're kind of corralling them in, making sure they follow our rules. Some basic rules, these are really hard to say, but an abstract class can contain abstract methods. A concrete class can't. It cannot contain abstract methods. Abstract classes can also contain regularly implemented methods, kind that people can just inherit without overriding. But a concrete superclass can be inherited by an abstract class. So I could have concrete inherited by an abstract, which then of course would have to be inherited by another class to actually create an instance of that class. So we have a lot of rules to deal with. An interface is a lot like a class, but it's a little different. An interface is really a contract between two classes. So if I have two classes that wouldn't normally have a relationship, like oh, maybe a circle and a square. They're both shapes, but they really aren't related other than that. We maybe calculate their areas differently. We might calculate the perimeters a little differently. So we're going to kind of look at that as an example is in one of your problems, in one of your exercises. An interface is really a construct, and it only contains constants and abstract methods. And what it does is kind of create a way for two unrelated classes to have a bond, like, again, a circle and a triangle can both have a calculation that calculates their area. We just have to do it a little bit differently. So we would have an abstract method that would have to be overridden. Now, an interface is treated just like a class in Java. See a lot of difference. We have some limits that we have to deal with, like in any programming language. A class can only extend one superclass. So a child class can only have one parent. But in Java, a class can implement one or more interfaces. And this rule is very different than C#. In C# you can only implement one interface, but Java gives you the ability to implement more than one interfaces. So you start seeing already the value of an interface. An interface itself can also implement one or more interfaces. So we can get things very, very related to each other and do a lot of inheritance and polymorphism in Java because of these abilities. But we do have some limits we have to work with. All right, let's do some code here. I'm going to leave this up for you. But while I do, I want to tell you that the other attachment to the announcement that I made is this geometric object class. So before you start working on this sample, you want to copy the geometric object.java class into your editor. And again, I don't care whether you're using Eclipse or Java Beans or whatever. Now, what we created in class is this code. Notice that we don't have anything in our main. We're not actually testing this. We're not implementing this. But what we're doing is practicing extending an abstract class. So take a look at the geometric object class. Let me get out of this so I can do that. Try to trick it and bring up Notepad here. I didn't have it up. I'm going to open that geometric class that I have out there for you. In our geometric object class, notice first of all that it is defined as an abstract class. We have a couple variables that we're setting up. We're really in our geometric object, we're concerned about colors and whether our object is going to be filled or not. We have a default construct where we've created an instance of our object without any parameters, and then we're constructing a full object with the color and whether it's filled or not specified. We set those values. Now what we really want to look at is notice that we have some abstract methods in our abstract class. First we have a get area, and then we have get parameter. And these, notice, is just a signature. We declare them as public and abstract, and then their return data type, and then their name. We don't have any code in here. So by doing this, we're saying, hey, whoever implements me has to implement these methods because they're required if you're working with a geometric object. And I can't tell you how to implement it because depending on what kind of object you're working with, it might be done differently. So in our code, we're going to implement a triangle. So if you would go ahead and bring this code up beside your editor and type it. You don't want to copy and paste. I know that it's really easy to, but it doesn't give you the benefit the same as if you enter it yourself. So go ahead and type this in. Notice how when you extend the geometric object with your new triangle, triangle new, we are going to give our triangle 3 sides. We have a default constructor with no parameters. Then we have our constructor with our parameters. We set them up. at this point, you should see, if you haven't implemented these methods yet, that you have an error being thrown on your triangle new class, your extend statement basically. And what it's telling you is you've got to implement the get area and the get perimeter. To do a get area on a triangle, we've come up with this formula. Notice it's a little different than what you might have learned in geometry because we don't know the height of the triangle. So we're having to add up our sides and then do some square root processing to calculate that. And then to get the perimeter of our triangle, we're just returning, oops, those should be plus signs. Don't get confused there. They should not be asterisks, so I'll let you fix that. But in this implementation, once you're done, you should see that this program will compile. You've successfully extended the geometric object. Good luck working on your assignments this week. Please let me know if you're having any problems or if I can help. They are pretty challenging considering it's been a while since you've been working on Java. So again, please reach out if you need some help. Thanks so much.